So when we're talking about the area of the shape or irregular shape, what's the first thing pop in your mind? Normally, the first common thing will pop in your mind is that we use the formula, right, to calculate the area, like the rectangle equals the length times the width, and the triangle equals base times height divided by 2, right? This is always that firstly pop up into our mind how to dealing with the area problem. For example, like this one, very commonly we can see the base here is 1, and the height here, which is perpendicular with the base, is 2. So the area is going to be very easy. It's half of 1 times 2. So it's going to be 1 unit, right? That's a very, very common ideas. That's all we always think about. Second one is that if we're dealing with some irregular shapes, for example, like this one, we can easily think, okay, I can basically cut the irregular shape into the regular shapes and then adding them together. So for this one, we can adding them by adding the area of the rectangle plus another triangle. This is another second common strategies we think about dealing with areas. Last one is that we can subtract instead of adding them together. For example, like this one, we might not know straightforwardly how the shaded area this triangle is, but we do know that the triangle A, B, and C, we can easily get their area. Then we use the whole square area to minus this 3 triangle to get what we want. So that is normally very common 3 strategies when we're dealing with the areas of the shapes, no matter it's regular or irregular shapes. But here today, what I want to share with you is another concept, which is called unit area. The concept of unit area is if we could, through the cut or rearrangement, to make the whole area into the equal unit area, or we can say we make it into the identical shapes, and then that's going to be help us to calculate the whole areas. Let me look at the example. For example, like the first one, if we don't know the total rectangle, but if we can know, okay, this rectangle consists of the 6 identical squares, then if we know the one area of the square, and then we can easily times by 6 to get the rectangle. Similar like the second example, if we know the area of the triangle, and then we can use the lines to cut the whole parallelogram into the different shapes of the triangles, and then we times them to get the whole area of the parallelogram. So for the last one, it is the same. If we can get the 1 unit of the sextagon, and then we can just time the numbers of the sextagon, and then to get the whole area. So basically, that is how we're using the unit area, which is the identical shapes that we can cut the shapes into, and then times the numbers to get the whole area. Let's look at this example. So when we look at this question, they tell us the area of ABC, which is the triangles outside, the bigger triangle, is 100. Now the question asking us, what is this smaller one? What's this small triangle the area is? So when we first look at this question, it seems like a little bit hard to break it down because we only know the big one, but what's the relationship between the big one and the small one? We don't know, right? So, and also they didn't tell us the base or the height of the small one, so we cannot use the formula, and also we cannot use the sum or the subtraction because there's no intersection between the small one and the big one. Seems like we are stuck in here. But think about it. If we look at this smaller one as the unit shapes, is it possible we can cut the bigger area triangle into the identical smaller one? The answer is yes. So if we can just simply count clockwise the smaller triangle by 60 degrees, then that's what we're gonna get. If we're looking at this way, we will find out actually we cutting this bigger triangle into 4 identical small triangles, which is I'm showing here to you, right? So since the bigger one is 100 and the small one we are asking actually just 1/4 of the whole area, so we can easily to get. So the triangle DEF, the area should be the 100 times 1/4, so that equals 25. This is a very special thinking skills that we can have to dealing with the to get area of the shape. This is a very good example. So by using that example, let's look at this one. You might just pause the videos for a little bit of seconds to give yourself a little bit of time to think about if you are to ask to searching the answers for this question, what you gonna do? So let's look at it. So the square of the EHGH, which is the one is inside here. If the area is 80, now they ask us what's the area of the ABCD, which is the outer one. How can we set up the relationship between the inner one and the outer one by cutting them into the identical small unit areas? Similar with the previous one, we can think about to say we clockwise 90 degrees about the small squares inside. Then that is what are we gonna got? We further cut diagonally with 2 perpendicular lines. Then we can find it out. We cut the whole ABCD, the area ABCD, into the identical triangle, which is this is the unit price, right? So we know that since the EFGH is 80, so for this one triangle, small y triangle, this we got 4 of it equals 80. So every one small triangle, the unit one, is 20. Then let's count for the whole area ABCD, how many this unit is inside, right? So we can find out actually it's 8. Yeah, it's 1, 2, 3, 4, right? Up to 8. So that is why every single one, is 20. We got 8 of it, so 20 times 8, that equals 160. This is another example. Okay, so I will leave this question for you guys as they practice. So after you read it, you might just work it out by yourself. If you want to know the answer, you might leave your comments under these videos and I can send the answer to you, or you can just share the answer with me on the comments. Okay, thank you guys. I'm really tired for today, but I'm happy to stay with my friends. Oh, sorry, stay with my students as long as they can learn anything from that. Okay, cheers guys. I will see you tomorrow.